Hello everyone and welcome to the APAC Groundbreakers virtual tour. My name is Gavin Soorma and welcome to the Oracle Multitenancy hands-on lab. In the course of the demo, this is the agenda we'll be following. So the topics we'll cover includes hot cloning of a pluggable database, on-ramp relocation of a pluggable database from one container to another, application container databases, Snapshot Carousel and Fleet container database, which was added in 18C, container map feature that enables us to create pluggable databases like partitions of a table, enforcing security in pluggable databases through lockdown profiles, and also ensuring memory can be set now at Pdb level as well. So we have memory limits for pluggable databases. Using dbca silent method to do a remote clone from one container to another container, and also remote cloning of a local pluggable database. We'll end the session with pluggable database performance profiles. So if you would like a copy of the VirtualBox image that we are using for the hands-on lab, as well as the notes of all the commands that we're using in the labs, kindly do send me an email through the following email address, prosolutions@gavinsoorma.com, and I will send you a link where you can actually go and download the image from. So with that, let's very quickly go into the demo. Just give me a second to get the environment ready. So right now we have two container databases, CDB1 and CDB2, both on the same host. It's Linux and Oracle 19.8. So let me quickly show you what we have currently set up. So when you install the image, this is what you should be able to see. Two container databases, CDB1 and CDB2. So container database CDB1 has just a single pluggable database called Pdb1. And if I connect to container database CDB2, which is also on the same host, you may need to start the database up. And let's have a look at what's there in CDB2. So in container database CDB2, we just have the seed database and there's no other pluggable database in CDB2. So that was a bit about the environment that we have. So the first lab that we will do is actually the hot cloning. So let's look at the various steps that we'll follow in hot cloning. So hot cloning was part of Oracle 12 Release 2, and cloning of a pluggable database was there in the very first version of Multitenancy, part of 12C Release 1. The only problem there was that we had to put the pluggable database into read-only mode first before we did any kind of cloning. So that was a bit of a drawback, especially for production environments where we could not put databases into read-only mode for clones. So now there is a property called local undo, and that is enabled. When you create a database, the container through dbca, in one of the screens, you will see the option to either select or deselect that box. The default is enabled, and local undo is required for us to do the hot cloning. So what does local undo mean? That means each pluggable database has got its own individual undo table space. So just to verify that, you can actually connect to the container and have a look. So we can see local undo enabled is set to true. So for the course of the demo, we are going to create a user called demo. And in that demo schema, we'll create a myObjects table, and we'll be inserting some data into this myObjects table. And we'll be using this particular table for most of the demo. So let's go quickly and create the user. and we insert some records into the My Objects table. So to simulate a hot cloning, what we're going to do is that now we have created the demo user. From another session, I will connect as a demo user and insert some records into the My Objects table, but I will not commit at this stage. And this is to simulate a case where we're doing a clone with in-flight transactions happening. So typically what we'll see in a live environment. So I'm going to connect as a demo user and run an insert statement, but don't commit as yet. So we have two sessions. In the second session, I'm going to connect as a demo user. I'm going to insert data into the My Objects table. So I'm going to add some more records, but I'm not committing this as yet. And back in session 1, I'm going to create a pluggable database called Pdb2 from Pdb1, and we use a file name convert clause to just change the path. So if I were to connect to the container database, so create all the pluggable databases while connected to the container. So we can see the data files for the container for the pluggable database Pdb1 as well as the seed. So now I'm going to issue this command. I'm just making sure that this commit has not been done as yet. And I go back here and I issue the commit now. So my pluggable database is now created. And I can go and open it. Now let's do a count of demo.myobjects. And if I were to do the same command in my session that was doing the insert, I see that these records now are available in my clone database. So that was an example of doing a hot clone. The next part of the demo is doing what's called an online relocation. Pardon me. So right now we have Pdb1 and Pdb2 located in container database CDB1. The objective here is to online relocate Pdb2 from container database CDB1 to CDB2. So what do we have to do for that? So we're going to use the database link, and the link is actually from CDB2 to CDB1. So the first thing we have to do is that we have to ensure that we have a DNS name entry for Pdb2 setup. So just let's go have a look at that DNS names file. Just ensure that we have it set up. So we do have entry for Pdb2, that's good. So what we're going to do now is that we're going to establish a session that connects to Pdb2. So right now Pdb2 is located in CDB1. So this is my second session. Sorry about that. So I've connected now to Pdb2 as a demo user. And what I need to do now in CDB1 is create a user that's going to be used for creating the link from CDB2 to CDB1. So we're going to create this user called C ##. That means it's a common user, link admin, and we grant some privileges to that user. So this is to be done in CDB1. So we gone and created the user and given some grants. Now connect to CDB2. And here is where we're going to create the database link from CDB2 to CDB1 using the user that we just created in CDB1. So I can ignore the startup part because I've already started CDB2, and we'll just verify that the link works. So going back into CDB2 now. So we can see that the link is fine. It's working well. So this is the link from CDB2 to CDB1. And now what I'm doing now in CDB2 is that I'm creating the pluggable database PDB2. Right now, PDB2 is still in CDB1, but I want to do the relocation. Notice this clause here, relocate availability max. So it's going to do what's called an online relocation for me, from one container to another. So I'm using the link that I just created. So right now I still have users connected to PDB2, right? In the original PDB2 that was on CDB1. So this user session is still connected there. So what I'm going to do now, if I were to check the status of this database, it will show status as relocating. So right now the database has not been relocated as yet. I still have active user sessions in my source that are making some changes, for example. So I'm going to connect now. I already have connected, sorry. I'm just going to insert some data now into my objects table. So this is my demo session that had connected earlier. And note the count of rows that are there right now. So now what I'm going to do is that I'm going to complete my relocation by issuing the alter pluggable database pdb2 open command. So this command will basically disconnect all my sessions now and complete the relocation. So when that command starts here, so what we're going to notice is that if I try to run count from here, it shows that this database is being shut down. The sessions are being disconnected. And this pluggable database now is being relocated. So if I were to check the status now of PDB2, it should no longer say relocating, it should say normal. All right, so that is done well. So now I want to ensure that the last changes I made have come across. So I'm going to connect to PDB2. And let's have a look at what is there in this table. Which matches what we had just before it got disconnected. So the last few changes have come across into the PDB2. So right now PDB2 is on CDB2, that's fine. And what about the original PDB2 that was on CDB1? We can go and remove that. So what we can do now in this case is that we can just go and get rid of this pluggable database, which has been relocated. So right now we have PDB1 in CDB1 and PDB2 has been relocated to CDB2. So that was the example of the online relocation. Let's look at the next part of the demo, which is called Refreshable Pluggable Database. Now this feature is good, like if I want to have an updated copy of production, and from this copy, then I can go and create multiple test development databases because my developers need an up-to-date copy of production to do some kind of debugging or proof of concepts or some kind of testing. Here, what I can do is that I can create a refreshable pluggable database, which is actually a read-only database but it is refreshed at predefined intervals. We can define the interval that it's refreshed at. And then what happens is that using this as a source, I can go and create multiple clones, which are read-write in nature. So in CDB2, using the same link that I had earlier created, I'm going to create this pluggable database called pdb1_ref using pdb1 in CDB1 as the source. And I'm specifying refresh mode. Obviously, this you won't do in production, but just for the demo, I'm doing that. So I'm going to create this pluggable database now in CDB2. So I'm setting my environment back to CDB2. So I'm creating the refreshable pluggable database with the refresh mode of every 5 minutes. Let's see what's going to happen if I try to open this database. It'll tell you now that this database can only be opened in read-only mode. So, okay, fine. Let's go and open this database in read-only mode. That's good. So now what we're going to do in the source is that we're going to go ahead and make some changes. So I'm going to connect as a demo user to PDB1. That's my source. And I'm going to make some changes to the my objects table. So this is my source database. So I added some more records to the table. Now I'm going to actually do what's called a manual refresh. Typically what would have happened is that every 5 minutes, as per the refresh interval that we have specified, the database will get refreshed. So to do a manual refresh, we got to close the database first and then issue a refresh command. So I'm going to close the database, issue the refresh command, and then open it read-only. Okay, once that is done, I'm going to connect to the pluggable database pdb1ref, and let's have a look at what's there in the demo.myObjects table. So we can see 201606, and the same value is here. So whatever changes were made on the source have now come across to the refreshable pluggable database. So if I were to leave this running every 5 minutes, it will do a refresh automatically for us. To save space, I'm just going to shut down the database and actually go and remove it, because we will not be using this database for any further part of the demo. Okay, so we're back to PDB2 only. This is on CDB2. So the next part of the demo is creating what's called application container databases. So like how you have the root container and pluggable databases, you also have a concept of an application container, and each application container can in turn contain its own set of pluggable databases. So the difference out here is that we're just using the keyword here as application container. Otherwise, the create pluggable database command is exactly the same. So I'm going to just go and create this pluggable database here. So we're doing this now in CDB1. So once the application container database is created, I'm changing the container to the application container. And now within the application container, I'm creating two more pluggable databases, PDB HR1 and PDB HR2. So these are created within the pluggable database. And if you see out here, these pluggable databases within the application container are being created using the seed database as the source. So this is called cloning using the seed. So I'm just creating two scratch databases now. So I've created the pluggable database. I connect to the container and create the other two databases. Okay, so let's have a look at the concept of application. So now within an application container, we can create what is called an application, where you give it some name and give it an application version, which is an arbitrary number. And then what we do, we create some, encapsulate the begin install and end install commands with some commands to create objects or users or grants or DML or DDL. So the difference out here is that I create a table now with the keyword called sharing equals data. That means the table that I'm creating out here called regions, the data is going to be common for all the pluggable databases. So think of it as master data that is going to be shared by n number of pluggable databases that are hosted by the application container. So this is like a concept of master data. So let's have a look at that, how it works. So we're going to basically open the pluggable databases now and create the application. So alter pluggable database command, application, application name, begin, install, and the version. And you have to always end it with the end install. And this needs to be run from the application container. So we can have a look at the status from a view called DB applications. So we can see region app. Okay, so now we have made some changes via the application. Now, can we see those changes straight away in the pluggable databases? The answer is no, until we do this command called sync. So if I were to connect to Pdb HR1 and do a select star from app owner regions, it will say table or view does not exist, because at this time the pluggable database does not have any idea about the changes that the application has made. So now we go and synchronize that pluggable database with that particular application. Issue that command sync, and now if we issue the same command, we can see the table regions and the data that's there. So this is like a master data. We can't go and update or delete or drop the table. So now I'll do the same thing. I'm going to connect to Pluggable Database 2, do the synchronization, and then select. So you can see even PDB HR2 sees the same data as PDB HR1. What happens if I try to issue a drop command? It will say that this operation is not allowed from outside what's called an application action. So that means the application can only be executed from the application container. So the individual pluggable databases can't do anything in terms of the application. It can't go and drop or add a column or change the structure. And even if you try to do insert now, it's going to fail, because the sharing was actually data. So this one would also fail. In the next example, we're going to change the sharing to move from data to metadata. That means only the structure would be the same, but each pluggable database can insert their own data. So let's have a look at how that works. So we're going to use the same application in this case. And I'm going to now say upgrade. So we make some changes. What are the changes we're making? We're dropping the table, and we're creating the same table now with sharing equals metadata. Okay, and if you see out here, I'm not inserting any rows into the table. So end upgrade, begin upgrade, and some commands in between. So ensure that this is always run from the application container, and a begin upgrade should also have an end upgrade. Okay, so you can see upgrading here, table drop, table created. So now I'm going to again synchronize the application with my pluggable database, Pdb HR1. And now what I'm doing now in Pdb HR1, I'm inserting some data. So early on, we could not insert any data, but now the sharing is only related to metadata. So that means the structure of the table is going to be the same, but each part of a pluggable database can have its own individual data. Now I change the container to Pdb HR2, and I'm going to insert some other data into this table. So app owner regions table structure is the same, but data is going to be different. So you can see out here, this one has got north and northeast, and the other pluggable database regions table has south and southeast. So similarly, if I try to do a drop, so insert works fine, but I can't go and drop the table. So now let's have a look at the third change we're going to make. So we're going to upgrade this application once again, now 1.1 to 1.2. The change we're making now is something called sharing equals extended data. And here we insert one row as part of the application deployment. But then what can happen after this is that each pluggable database can insert its own set of data. So some data is like master in type, and some data can be inserted by the individual pluggable databases. So this is a combination of both data and metadata. So you can see it's called extended data. So the same thing I'm going to do within an application, begin upgrade, end upgrade. So drop the table, create the table again, and insert just one row into the table. Just ensure that this is always done from AppCon. Okay, so now I'm going to do the same resynchronization once again. Connect to Pdb HR1. We can see there's one row in the table. So this was actually the row that was part of the deployment. But now what you can do is that you can insert another row into the table. So now you have north and northwest. And I'm going to connect to Pdb HR2, do the same thing, but insert some other data for the second row. So you can see out here, so this one had north and northwest, and this was north and northeast. So you can't go and delete this row, but you can possibly go and change this row. So I'm just going to remove these containers just to free up some space. So I just showed you here where a mistake is made. You can't drop the pluggable database unless it is closed. So what we need to do, show the contain name. We can do it like this, auto session, set container equals appcon1. Now this command should work. And we can get rid of the second one as well. So if I issue the show PDBs command while connected to the application container, I don't see any other pluggable databases within that. If I connect to the root, same command, appcon, okay. So now let's have a look at another feature that's pretty nice. It's called Snapshot Carousel. You may find that this feature requires us to simulate Exadata, because if you run this command to create a snapshot database, it will say this is not supported. So looks like this feature has been disabled from on-premise. So I'm running this command to actually fool the system to think that it's Exadata. And then I'm going to be able to create a pluggable database with using the snapshot carousel feature. So let's quickly just do that first. So I'm just going to have to restart my database. So while the database is being restarted, let's just talk a bit about these snapshots. So what you can do with the snapshot is that by default, 8 snapshots are created. And these snapshots are very small archive files. So they are scaled down totally for versions of your database. And they can be used for like any kind of testing or even for recovery. So like for example, you can say every day create a snapshot, and then you have 8 copies of your database in theory. And if you're doing some kind of testing, you can also create 8 copies of development database, because your developers want to check things out, make some changes, but they want to roll back and go back to maybe a previous day or a previous week. So then in that case, the snapshot copies are pretty useful, because you can just uh, create a snapshot copy from one of the snapshots and you're good to go then. So in this lab, we'll simulate like a case where we go and truncate a table. So some kind of failure has happened, or unwanted human errors happened, and you want to recover from that. Then you can go back to a known snapshot that has a good data and use that to retrieve the data for the table that has been truncated. So hopefully my database is up and running now. So if you issue this command, we can see the property name, max PDB snapshots, and the value is 8. Maximum number of snapshots for a given PDB. I'm not too sure if they can be amended from 8. I'll have to check and get back. I think the value is fixed at 8 at the moment. I could be wrong. So now what we're doing, we're going to create a pluggable database, and I'm specifying a snapshot mode every 2 minutes. So every 2 minutes, a snapshot is going to be taken, and we are specifying PDB1 as the source. So our pluggable database is created. We can go and open it. And now I can actually query the DBA underscore PDB snapshots to get the names of all the snapshots as well as the SCN numbers, among other things. But because we have specified the snapshot mode of every 2 minutes, a snapshot is only going to get created after approximately 2 minutes. So maybe this is a good time for us to take just a 2-minute break, and we'll come back, and hopefully by then the first snapshot would have been created. So just be back in a couple of minutes. So let's see, hopefully some snapshot has been created. Okay, so we can see one snapshot has been created. So what we're going to do now is that we're going to go and truncate the table. So I'm going to connect to PDB1 and truncate the table. So the table had 201,606 rows. Now it's truncated. So what I'm going to do next is I'm going to connect back to the root container and create what's called a snapshot copy and specify the name of the snapshot that this snapshot copy should be based on. We also need to ensure that this particular path exists. So let me quickly check that. If it's not there, you may need to create this directory structure. It's fine, it's there. So create pluggable database using snapshot. In this case, what is my snapshot name? I take that. And you may have to just replace this snapshot with your snapshot name, which could be different. Just change that value, sorry. So create pluggable database pdb1 snap copy from pdb1 snap. So pdb1 snap is based on what? pdb1. So pdb1 snapshot, pdb1 snap, snapshot copy now. Okay, so my snapshot copy has been created. I'm going to open it, set my container now to the snapshot copy, and then do a count star from the table. And hopefully the rows should be there. Okay, so we can see here, before the truncate, we retrieve the rows. And with the passage of time, we would see more snapshots being created. And these .pdb files are actually pretty small. So if I actually go to this physical directory, so you can see they're pretty small. But this is the snapshot that I used to go and create my snapshot copy. Okay, so that was the snapshot carousel feature. So the next feature we're looking at is something called Fleet CDB. So if I have a number of container databases and each container database has a number of pluggable databases, and I want to monitor all these from one central point, then I can designate one of my containers to be the fleet lead or the lead CDB. So what can you actually do from the lead CDB is that, for example, I can look at vSession or vlog or one of the CDB views of a container database or pluggable database that is not hosted in that particular lead container database. So from one central point, I'm monitoring other containers or pluggable databases that are part of my enterprise. So what we need to do in this case is that we designate one of my containers as the lead, and the other ones would be basically using this lead and connecting to the lead via a database link. So CDB1 is what I'm designated as the lead CDB. So let's go into CDB1. And we set this property to true. And we're going to create a user that's going to be used as the user for the links that all the other target containers will use. So again, a common user. And now I'm going to connect to my target. In this case, is CDB2. So if we had multiple containers, we'd have to issue the same set of commands in all the containers. So right now I only have CDB1 and CDB2, and CDB1 is the lead CDB, and CDB2 basically is going to connect to the lead CDB via a database link. So in CDB2, right now this property would not have any value. So let's have a look. Oh, sorry about that. So it does not have any value assigned to it. So this was the link we created in one of the earlier sessions. So I'm going to just remove this link, and we're going to create a new link with the user c ## lead user. So this user exists in my lead CTB. So looks fine. So what I'm doing now is that I'm going to set this property db link : the name of a link that I've just created. Okay, so I would have to do this in all my target, put it this way, target containers that want to actually be referenced from the lead container database. So I'm going to go back to my lead CDB. And I'm going to check a particular column. So you can see out here is proxy, it's showing CDB2, and in CDB2 there's PDB2 as well. All the rest are pluggable databases in CDB1. Okay, these are the snapshot copies that are being created, so just don't worry about those. So if I were to say alter session, set container equals PDB2, would that work? Probably not, because it says PDB2 does not belong to the current container database. But if I were to issue what's called a cross-container query that basically can connect to a number of containers, then maybe I can select from the fleet CDB that's the lead. I can access CDB underscore views, DB underscore views, $V views. That basically will reference all the other target container databases and pluggable databases. So from one particular database or one particular container that's designated as the lead, I can in turn actually monitor my other containers and pluggable databases that are part of what's called my fleet. So moving on to our next feature. So I think let's just issue these commands. I just want to stop the creation of the snapshots. Okay, so the next feature that we're looking at is something called container maps. So with container maps, what we're doing actually is that we are treating individual databases, pluggable databases, PDBs as partitions. So we designate a table as a mapping table, and this mapping table then will be used by other tables to actually go to the right database and retrieve data. So it's like when you talk about partitions, it goes to the right partition in the table. Here it's going to go to the right pluggable database and obtain the data that's needed for that particular query. So let's have a look at container maps. To free up space, I'm just getting rid of PDB2 as well. And guys, what you may need to do from time to time is this: just remove any archive log files, because you may find your disks are filling up with the insert statement that you're running. Just to keep the space managed. Okay, in this lab, we are connecting to CDB2. So I'm just changing my environment to CDB2 now. And I'm just going to go and remove this database. Again, just bring up some space. And in CDB2 now, have a look. We're going to create an application container database. So very similar to what we had done earlier. And in this application container database, I'm going to create two pluggable databases, pdb underscore amer and pdb underscore eur. And then I'm going to go and create another application. So let's go and create the application container first. And now within each application container, I'm going to create the pluggable databases. One step is missing, alter pluggable database. We can just add this step to the book. So now these two commands should work because the application container is open. Okay, so both my pluggable databases are created. Let me just add this line here. I think it's missing as well. And now what we're doing next is that we're going to go and create what's called an application. So we've seen creation of an application in an earlier example. The difference out here now is that we're creating what's called a container map table. So we're creating a table called app.owner.con map and partition by list. But what is different out here is that the partitions now correspond to the actual PDB names. So PDB MR, PDB Euro, as in EUR, and we assign some values. So these are the list of values, very similar to how we create a list partition table. And then we create what's called a container map. So we say alter pluggable database set container map is that table. And then this table that we create, sales revenue by region, would basically follow this container map table that we have set up to when the queries are run against this table. So let's have a look at that. So very similar to what we done earlier, begin install and end install. So all these would come in one application deployment. So we're creating the mapping table, and then we are creating another application table, and then enabling that application container application table to use the container mapping table that we are also creating. So let's have a look at this now. Just make sure you're always in the application container. So that's fine. So the application has been deployed, and we have to issue those very similar commands that we had done earlier, which is the sync command. So connect to each individual pluggable database, so pdb mr, pdb ur, and issue the synchronization command. Now, if I connect to pdb mr, I should be able to see the table. So I can see the table that was created as part of the application deployment, sales revenue by region. And now I can go and insert some data because the sharing was metadata. So that means I can go and insert data into this table. So now let me just go and insert some data into this table now while I'm connected to pdb_mr. Inserted some data here. Let's have a look and see what the data is in this table. And now I'm going to connect to the other pluggable database and do the same thing, insert some more data, but into the sales revenue by region table in that particular pluggable database. Okay. Now I'm going to go to the application container and issue some queries. So let's see what happens now when I issue a query like that. And I'm going to do an explain plan as well to show you what is happening under the scenes. So you can see out here, containers full and partition list. So it has gone to a single partition. The partition actually here is the database. So the database is pdb_mr. So only issued this list of values, value of US. That means it knew that it has to go to pdb_mr to retrieve the value. And if I were to run a different query, now changing the country to UK, behind the scenes, it would basically reference pdb_eur. But what I can do is that from one common location, I want to get data from both. I can also retrieve it like this. So I'm accessing data that's stored in two different databases here using the container mapping. So what happens now if I want to add another region, for example, now I'm going to create another pluggable database. So I call that PDB Asia, for example. And what is actually changing here is that I'm doing a container map update and adding another partition. So this is similar like adding a partition to a partition table, but the name of the partition actually is the name of the pluggable database that we just created. And we assign some values like India and China. So the next time you run a query like here, but change the country to say India or China, it would then go to the pdb_asia database to obtain the data. So I'll just show you that. So this is called the container map update. Okay. So quite a useful feature, I would feel. So let's look and see how lockdown profiles are implemented in a pluggable database. So lockdown profiles have been there even in 12c, but some enhancements in 18c and 19c was where you can actually create a lockdown profile based on an existing lockdown profile. So then you can have like a master profile, and that is referenced by other profiles. So if you want to make a change, you just make a change to the master profile. So I'm going to go and create a profile now in PDB2, and I'm calling this profile appcon profile. And I'm specifying what does this profile do. It disables the statement called alter user. So any alter user statements are going to be disabled with this profile. And I'm creating another profile that's based on this particular profile. Then I go to my application container where I'm going to enforce this profile. This application container has a number of pluggable databases as we saw earlier. And I'm going to set pdb underscore lockdown to the name of the profile that I just created. So this app pdb profile is based on the original profile that we had created first called app1 profile. So we had assigned some statements that are disabled to app1 profile, but they are also inherited by app pdb profile. So let's have a look at that. I'm now going to connect to my session, to my container database, and pluggable database now is pdb-mr. What happens if I try to use an alter user command? It will say insufficient privileges. So it's telling you that you're not allowed to issue this alter user command. And what happens if I try to say create user? Well, that should work, right? Because there's nothing preventing me from creating the user because this disable statement was just alter user. So I can go and create a user as well as go and drop the user. Now let's say I want to go and change my original profile to drop user. So I'm changing my master profile in this case. Drop user. So now the create user command should work. But if I try to drop the user, I'm going to get insufficient privileges. So I'm defining the privileges that are enabled or disabled at the master profile, and then that profile can be inherited by not one but multiple pluggable databases. So if I were to actually connect to another pluggable database, I would actually see the exactly same thing happening. So all databases in app1 would be restricted by this particular lockdown profile. So let's have a look and see what all is disabled now and enabled. You can see both alter user as well as drop user are disabled. So these are some default profiles, but this is the one that we just created, and you can see alter user and drop user commands are disabled. So there's lots of flexibility with what you can actually enable, disable. If you have a look at the documentation, there's a lot of control over what level of granularity you go to. So you can do a lot of you can combine statements as well, and you can put a lot of filters and conditions when this lockdown profile should be actually invoked. So I'm just going to free up some space again, just remove these pluggable databases that we don't need. And let's have a look at another feature that's pretty good. So early on when multi-tenancy first came out, we could not actually set memory at the pluggable database level. So there's no way of us restricting memory between PDBs. So if you had the container database allocated 2 GB SGA and you had 4 pluggable databases and one pluggable database was more important for you than others, you could not allocate more memory to that pluggable database. But now you can actually do that through what's called pluggable database memory limits. So if I were to actually connect now to my pluggable database, I can go and change some values at the application container as well. So what is my current value for STMX size? It's 800 MB. So you can also set min size now. So now I'm going to connect to application container 1. And I'm going to basically, sorry, application 1 is not there. Okay, I just removed it. So let me just connect to CDB 1. Okay, so let's set it for PDB 1 now. So if I issue the same command here, it should be, it's 1 GB. So what I'm going to do now is I'm going to change this to PDB 1. So I'm setting now a SJ target for this particular container. And I can also set a minimum size as well. So I have a maximum size, a minimum size. What happens if I try to set it at 200? You see that we'll get an error. So the minimum size has to be less than 50% of the SJ target. So I can set it down to 140. And I can also set some other limits like max IO as well. IO per second I can set as well. So here's how I'm restricting or enabling some resource limits of at the pluggable database level as well. So if I were to connect to another pluggable database, I can issue some different commands. So that way I'm allocating different memory limits to different pluggable databases that are hosted in the same container. So now we're going to do what's called a remote Pdb clone, guys. So what are we doing out here? We're going to use DVCA in a silent mode to actually go about and create this pluggable database. So now what I have is PDB1 in CDB1, and I want to go and clone it to CDB2 using DVCA and the command line. So for that, I'm going to go and now basically create this user once again. So I'm doing that in CDB1. So I've created a user called chHashes_link user, and I'm going to connect now to CDB2, and I'm going to create a new database link that's going to be used for the remote clone. I think we may have a small typo here. Yeah, there's a underscore missing. So let me just create this user once again. Sorry about that. I think there's, so you don't have the problem when you do the workbook. There's an underscore missing down there. I'm just going to drop and recreate this user once again in CDB1. And now when I'm connected to CDB2, the link should work. The password is not correct. So now if I were to run that command, okay, that's good. So what we're doing now is that we're going to use DBSCA and we're going to we're going to actually clone, do a remote clone. And typically what would happen in this case, in most cases, is that the CDB1 and CDB2 may be on different servers. And then from the target CDB2, you can actually run DBCA. That will connect to the source and do the remote clone, all in one single command. So have a look at the command we're running out here. So DBCA minus silent minus create pluggable database, create from remote PDB. This is my source. So I'm running it in CDB2. This is my remote PDB name. This is my connect string. And these are my remote sysdb users. So sys here, the password for sys. Put the link username and the link password. So this is the sys password on the target as well. I'm going to clone it as PDB2. So maybe you want to change the name. And this is the location of the data files where they're going to exist. So let's give it a try. So you can see the command create pluggable database using remote clone operation. So that looks to have gone well. Let's connect and have a look. So we can see PDB2 now has been created in CDB2. So this is the remote clone using the command line. So similarly, we can also do a local clone. So this is called a DBCA silent PDB clone. So now what I want to do is that I'm connected to CDB2 and I want to basically create a PDB called PDB1. I'm going to use PDB2 as the source. So I have PDB2 right now, and I want to use that as a source and create a pluggable database called PDB1 from that. And I'm specifying the location of the files. So let's see, this should work pretty well as well. So Pluggable database PDB1 has been created successfully. So let's have a look now. Just go in and issue the show PDBs command. You can see now we have PDB1 that was cloned from PDB2. So the last part, guys, is something called Pluggable database performance profiles. So similarly, how we could restrict memory at the Pluggable database level by using the parameters for the database. So you can issue the database memory parameters. You can also go and control resource allocation at the Pluggable database level by creating what's called these performance profiles. So we are using Resource Manager here to allocate shares. So typically you'll see these commands in Resource Manager, create pending area and create a plan. And here's a directive. So I have two directives here. The first one is called tier 1, the second one is called tier 2. And in tier 1, I'm giving 3 shares and allocating a minimum memory. So I'm allocating more resources. So when you talk about shares, it's like a ratio. And the second one is having less resources. So shares are 2. And I'm specifying a memory limit, which is much less than this one. And I'm also specifying what's called a utilization limit as well. So I go and create these two directives. And then this is very similar to your resource manager plan. And then when I'm connected to my container database, I can set this particular value to tier 1. And to the second pluggable database, I can set this value as tier 2. And then I can set the resource manager plan to profile plan. So that way I'm ensuring now PDB1 has a bigger chunk of memory resources, and PDB2, which is regulated by profile tier 2, now has less memory and also has some utilization resources that have been set, utilization limits that have been set for that particular PDB. So let's have a look at that. I'm doing this in CDB2 now. So I'm just going to issue this block, guys. All right, and now I'm connected to PDB1. I'm going to set the DB performance profile to tier 1. So have a look at what the current setting is. So it's not set. And I'm going to do the same thing for PDB2 and set the plan now via resource manager plan parameter. And we can actually view this $V view. So if you see this view, you can actually look and see what's happening in the database. This is real time. So you can see the Cone ID. So that will give me what is the particular pluggable database. And I can see lots of information about not only memory, but also about CPU and as well as IO. So based on the profile that's been set up, I can actually, that profile which you have set up is going to limit the resources for each pluggable database. And I can verify that by looking at this particular view. So this is resource PDB metric. So I can look at the different metrics for each of the pluggable databases. So that's how I can regulate performance. Sorry, not only performance, sorry. I can regulate the resources, the resource utilization. I can set resource limits for pluggable databases that are hosted by a container database. Whereas early on, I didn't have the option. I could only set, for example, things at the container, but I could not control how memory is allocated to individual pluggable databases. So guys, I think that's to the end of my demo. I hope you found it useful and enjoyable and learned a little along the way. If you do have any other questions, please feel free to drop me a line. My email address is mentioned in the first slide. And like I mentioned, if you do want a copy of the VirtualBox image and the notes for the labs, please do ping me on the email address I have mentioned there, Gavin, prosolutions@gavinsoorma.com. And keep in touch, take care, and bye for now. Thank you.